Welcome to HashSet. Store unique items instantly. Here is what we will learn. Let's get started. Why do we need this concept? Using lists or arrays can lead to duplicate entries, causing data inaccuracies. How do we store unique items? Lists allow duplicate entries. Manual duplicate checks are slow. Data integrity is compromised. HashSet automatically prevents duplicates using hashing for fast operations. How is HashSet used in the real world? Duplicate removal. Eliminate repeated items from lists. Membership testing. Check if element exists quickly. Unique collections. Store distinct items only. HashSet powers all these applications. Let's see the problem it solves. So what happens without HashSet? Checking duplicates manually in a list. Look at how messy the code gets. ON duplicate checks. Manual logic needed. Performance degrades. There has to be a better way. Here comes the solution. HashSet. Look how clean the code is now. O1 contains check. No duplicate elements. Fast add/remove. Compare the difference. And that is why we use HashSet. Let's see how to implement HashSet in code. Here is the implementation. Create HashSet. Initialize empty set. Add element. Insert apple. Add element. Insert banana. Add duplicate. Apple not added again. Check contains. Test for banana. Now let's see the output of this code. Quiz time. Test your understanding. What is the main characteristic of a HashSet? Which one is correct? The correct answer is HashSet stores only unique elements. No duplicates allowed. What does this code output? Which one is correct? The correct answer is HashSet ignores duplicate adds. Size remains 1. How to check if HashSet contains an element? Which one is correct? The correct answer is contains method checks if element exists in HashSet. What's the output? Which one is correct? The correct answer is remove. 2 deletes element 2, contains 2, returns false. Here's a challenge for you. What's the output? Comment your answer below. If you found this helpful, please like and subscribe.